Hello everyone, welcome back to this SWAYAM course, Introductions to Farm Machinery and Implement. In previous lecture, we were talking about metering mechanisms, different type of metering mechanism, furrow openers, different type of furrow openers for seed drill, seed cum fertilizer drill. We also talked about planting and planter, different types of metering mechanism for planter, and different types of planters as well, like semi-automatic and automatic. And in today's class, we will be talking about seed drill calibrations and seed damage assessment, which may happen in seed drill or seed planter. So, calibration of seed drill or seed cum fertilizer drill, in which the calibration is an procedure where we conduct the testing to assess the seed drill's correct seed rate. So here the seed rate, the word seed rate represents the amount of seed sown per unit area. So generally seed rate is expressed in terms of kg per hectare. If we take wheat crop as an example, so recommended seed rate for it is around 50 to 20 kg per hectare. So like that, seed rate will be always the amount of seed which may be sown per unit area for optimize the production. So here the calibration is the procedure where the testing is conducted for seed drill in order to check its correct seed rate. So it is very necessary operations, and every seed drill or seed cum fertilizer drill must be checked or must be calibrated before putting them into actual use, because we don't know, whenever it is new, we don't know at what for what seed rate it has been set. So unless we check it, we will be unable to find what amount of seed we may require to sow in our land. So for that reason, a seed drill must be calibrated before we put into actual use. So it may be whenever the seed drill is new, it requires calibration, or if seed drill is gone wrong due to some operational or some accidental accident happens, there it may undergo repair and maintenance. In such cases also, there might be disturbance or distortance happen to settings which we have made into that seed drill earlier. So in any seed drill which we are using it at very first time, it requires a calibration. So calibration is done to get a determined seed rate of the machine. So we have a control in all seed drill or seed cum fertilizer drill, even in planter, to change the seed rate. So we can change according to our requirement. So conducting calibration, we can able to judge at what seed rate it is having and what is our requirement. Accordingly, we can set it. So this is the this slide onwards will tell you the steps to be followed while conducting the calibrations for any seed drill, seed cum fertilizer drill, or even for the planter, seed planter. The very first stage or very first step followed while calibrating any sowing equipment is to determine their working width, so nominal working width. For the seed drill, seed cum fertilizer drill, or for the planter, seed planter, nominal working width of any seed drill will be determined by counting the number of furrow openers it is having and spacing between each furrow opener. So with this expression, that is W is equal to M into S, where M is the number of furrow openers any given seed drill or seed cum fertilizer drill or planter is having, and spacing between the two furrow openers will help us to determine its working width or nominal width of that sowing equipment. Once we determine the width, the next will be to determine the length of area, the length the seed drill has to move or travel in order to cover 1/25 hectares of area while it is having width of W. That is as we determined in the point number 1. Any seed drill having width W, how much length it has to travel in order to cover 1/25 hectares of area it must be determined. So for that we use the expression L is equal to 10,000 by W into 1/25, whereas 10,000 is the area in 1 hectare, that is equal to 10,000 meter square. W is the width, that is also in terms of meter as it is determined in step 1, and again multiplied it with the 1/25 because we are calculating it for the 1/25 hectare area. and that's how it becomes 400 meter by W. So W is the width of any given implement which we have taken. So that will give you actual length. The seed drill, this equipment has to travel in order to cover 1 by 25th hectares of area. So this is the seed drill. These are all the furrow openers. There are around, in this particular case, 1, 2, 3, 4. There are 9 furrow openers are there, 4 at front and 5 at the rear. So that's how the hem will become 9, and space in between each furrow openers will be measured with the help of a tape or say scale, and that's how the S will come. And with the help of this W, M and S, you will come with the width of the implement. Once width is known, with this much of width, what is the length L you must, the implement has to travel in order to cover 1 by 25th hectares of area. So for that, expression is used here, and from that you will find the L. So after L is determined, then you need to find out what is the number of revolutions the ground wheel has to make. So here it is the ground wheel. Here it is the ground wheel. So it is also called as transport wheel. It is also called as drive wheel. Drive wheel, transport wheel, ground wheel. Like that it is always, synonymously called. So once the L is determined, then we need to find out what is the number of revolution this drive wheel has to make in order to cover the L, the length L. So which is determined by using this expression, where it is pi d is the linear distance the drive wheel will cover in one revolution, and n is the number of revolution it has to make in order to cover the distance equivalent to L, which is measured in the step number 2. So after simplifying this, the N will be like 10,000 meter square divided by pi d W. So pi d is the circumference which the drive wheel will make in one revolutions. Width is the total width of implement. W is the total nominal width of implement, and with this 1 by 25th hectare area it is going to cover, and that's how the number of revolutions will become like this. Once we determine the number of revolutions required to travel L meters of length with the W meters of width of the given implement, then our actual experiment began in order to calibrate the machine. So how the next step is jack up the drill. So drill must be kept away from the ground. Then only you can able to rotate this drive wheel. So if this drive wheel is not, so the next once that number of revolution is required is calculated, then you have to determine the actual experiment will begin. For that, the drill must be kept clear from the ground. So it must be kept above the ground so that you can able to rotate this drive wheel. So drive wheel or ground wheel, it must be free to rotate. So that is only possible whenever you jack it up, that the entire drill. So once the it will be jacked up, then we will mark on the drive wheel somewhere. We will mark with the help of a marker, and we will also mark corresponding mark on the implement as well. So we will mark like this, and it will help to count the number of revolutions the drive wheel will make. So jack up the drill so that the ground wheel will freely turn. It will be we can able to rotate it freely. Then we will mark on the drive wheel as well as the corresponding mark on the convenient place on the body of the seed drill or planter. In order to count the number of revolution, we are going to rotate that drive wheel. So the number of rotation we are going to make is equivalent to the n which we have calculated, the number of revolution which we have calculated here at the point number 3. So meanwhile, we will also put a container or a sack at the individual furrow openers in order to receive the seeds or fertilizer which are being metered by the metering mechanism. So for that, we will keep the container in individual furrow openers, and the individual furrow openers will collect the seed as the metering mechanism will rotate. So meanwhile, we will also select the seed and fertilizer for which the seed drill is being calibrated. So once the container is being kept, then we will also adjust the rate control lever adjustment. So rate control lever adjustment is a special kind of arrangement. As you can see in this picture, here there is a lever. So this lever, with the help of this, we can able to move the metering units to the left or to the right. So if it is at the center, then it is at optimum level. If we move to the right, then it will bring the metering mechanisms into the they will bring the grooves of metering mechanism exposed into the seed, and that's how they carry more seeds. If you bring them, if you move this lever to the left, so they will reduce the length of grooves exposed to the seed, and that's how the quantity of seed being metered in every revolutions will be reduced. So in order to, while calibrating, the care must be taken that it must be ensured that rate control adjustment lever must be kept to its maximum. So it must be kept to its maximum so that the calibration will start from the maximum seed rate. If you are not getting the desired seed rate, then we will reduce the control lever, this rate control lever, and that's how the seed metering mechanisms will be brought away from the seeds, or the exposure area of the grooves which is exposed to the seed for metering will be brought down or will be reduced. So that's how the metering rate will be minimized. So once the rate control adjustment is made, or it is put into the maximum drilling level, then the each for openers are provided with the container or sack to collect the seed, and then the ground wheel will be rotated to a revolutions as it is determined in point number 3, and because of that we will be able to collect some quantity of seed and fertilizer in individual hopper, individual container or sacks at the individual for opener, and we will weigh those fertilizers and seeds collected, and we will calculate it for 1/25 hectares of area. This is the quantity of seed being metered, and similarly through cross multiplication we will find out what is the amount of seed which will be collected in 1 hectare of area. If that seed rate is higher than what we desired for, then we will reset the control rate to some minimum level. Then we will repeat the procedure from the point number 3, point number 4 to point number 8, and that's how this process will be repeated again and again until we obtain a desired seed rate for the given crop and fertilizer. Okay, that's how the calibration is done. So calibration is done for seed drill, seed cum fertilizer drill, or seed planter. So from that we can able to understand what is the seed rate our given seed drill or planter is providing us. Okay, the next topic is test for mechanical damage of seed in seed drill or planter. So in seed drill or in the planter, there might be chances where the seed may get damaged mechanically. So any seed which is get damaged or mechanically damaged will have lower viability, in the sense they will not germinate. The chances of germinating those mechanically damaged seeds are very less, and that's how in future the plant populations will be less if that seed drill is producing more mechanical damage into the seed while it is sowing or planting. So one must ensure that is equipment which is being used for sowing must produce very less amount of mechanically damaged seeds. So how we are going to measure the percentage of mechanical damage which may happen to the seeds in the seed drill or in the seed planter? So that is assessed by taking the quantity of given quantity of seed, place it into the seed drill, and collecting the same quantity of seed from the metering mechanism at the from the seed drill after metering, carrying, and depositing of seed is being done. The raw seed, seed which are placed into the seed box, and the seed which are collected from the furrow opener. So both of these sample are taken and they will be checked for physically damaged, mechanically damaged seeds, and they will be later by with the damaged seed at the numerator and input seed at the denominator, and that's how the percentage of mechanically damaged seeds will be determined out. So the question is, what are all the spot or the place, I mean, a spot or the locations within the seed drill where the seed may get mechanically damaged? The places where, I mean, possible points where the seed may get damaged in the seed drill or seed plant or seed cum fertilizer drill, or the like at the metering unit. So metering unit, the metering unit will have a motion, and while it is moving, it will carry the seeds. So there will be a friction between the moving parts and the seed, and that's how the high chances are there for seed to get mechanically damaged. Other than that, seed carrying pipe, seed tubes or seed pipe, if internal surface of the seed tubes are not smooth, so there also seed may undergo experience the scratching while traveling from the point where the seed pipe received the seed from the meter mechanism and to the point where they will be deposited at the furrow. Other than these two, cutoff devices and knockout devices are also certain component where the seed have more chances of getting damaged. Cutoff devices, they tend to wipe off extra seeds, and that's where the chances are there for seeds to get mechanically damaged. And knockout devices are device mechanism where they work on removing the seeds out of the cell at the delivery sprout, and for that they articulate the seed drill metering plate, or they may impose some mechanical force on the plate to eject the seed out of the cell, and in such cases also the seed may get damaged. So these are all the points in the seed drill where seed may get mechanically damaged. So how we are going to assess them? So for that there are two methods. One is the sticky belt method, another one is a sand bed method. With the help of this method, you can assess or determine or check the percentage of seed which are mechanically getting damaged. In case of sticky belt method, as its name indicates, there will be a belt with the sticky surface on its surface. So the seed will allow to fall after metering is done over this sticky belt, and as that seed drop over the sticky belt, that the seed tend to stick on that belt, and from there we can able to physically see what is the status of that seed, whether it is damaged, whether it is broken, or any internal damage it is happened, we can able to examine it. So for that, sticky belt methods are used. As you can see in this picture, the experimental setup is shown in this picture where the seed drill is jacked up, and one of the seed metering mechanism is fixed above the rotating belt. So where the rotating belt is having a sticky surface, the grease like material will be coated on that rotating belt. The length of the belt will be around 10 meter, and it will rotate between this 10 meter only, and it is having sticky surface over it. And over this rotating belt, that meter furrow seed box and seed box equipped with the metering mechanisms are placed. So within the metering mechanism, there will be a cutoff cutoff mechanism as well as knockout mechanism. So they all will tell us, I mean, we can able to assess the damage which may happen at that point. So as the seed metering mechanism meter the seed, and that metered seed will fall over the sticky belt, synchronization will be made with the speed of belt as well as the speed of metering unit in order to observe the real working condition as it happens in case of field experiment. So like that, here the with the help of sticky belt method, the mechanical damage which may happen to the seed at seed metering unit point, at cutoff mechanism point, at knockout mechanism point will be assessed. In addition to the seed damage, we can also able to assess here the uniformity of seed. As the seed fall on the sticky belt, they tend to stick there only. So that allows to examine what is the spacing the seeds are being maintained while they are falling on the furrow. The another method is the sand bed method. So one that you are seeing in the screen is just an sand bed, but not exactly the one which we use for assessing mechanical damage or any other with the help of a seed drill, but it will look like this only. So The sand bed is a artificially made bed with the length of about 5 meter, and the entire bed will have a 25 centimeter depth of bed, and that bed is full of sand material. So only sands are placed in that bed to a depth of 25 centimeter, and that bed length will be around 5 meter. So in this bed, that seed drill will be pulled, and everything will be in process, like drive wheel will rotate, and that will provide a motion to the metering mechanism will collect the seed out of the seed box and deliver them into the delivery spot, where the seed pipe receive it and put them into the furrow opened on this sand bed. So once that equipment passes through the 5 meter distance, then equipment will be taken out of that bed, and examination will be done to collect the seed out of the sand bed, and their mechanical damage will be assessed, and percentage of mechanical damage any given seed drill which we have tested will be designated with the percentage which we have observed in that examination. Like that, seed bed method and sticky belt method will be used to assess the mechanical damage the seed may get while metering, or metering to the metering and dropping into the furrows. In addition to that, these two methods are also used to check the plant to plant spacing. If it is a planter, then we can able to check plant to plant spacing as well, as that seed placed on the sticky belt will tend to stick there only, they will not bounce, and that's how that help us to determine the spacing as well. So these are all the references you may use for further better understanding and deep information regarding calibrations of different types of sowing equipment, as well as assessment of mechanical damage, as well as the uniform spacing of seeds in the sown while sowing in the field. Thank you all.